Okay, think about this for a second. What are the two most complex systems we even know of? On one hand, you've got the digital computer, right? A whole universe of pure logic, all built on ones and zeros. And on the other hand, you have the human mind, this incredible universe of feeling and meaning and just experience. Now, for decades, we've used one to try and understand the other. But what if that metaphor is actually way more literal than we think? Could our consciousness, our very sense of self, just be a really, really sophisticated program running on the hardware of our brain?
So let's really break this down. Over here, we've got code. And yeah, it's about logic, it's about machines, but at its absolute core, it is all about syntax. It's just the formal rules for how you arrange symbols. But then you have consciousness. It's about feeling, being human. And that all comes down to semantics. The actual meaning behind all those symbols. This entire explainer, it's all about the massive gap between these two worlds and some of the incredible theories trying to build a bridge across it.
So, if we're going to really explore this idea of the mind as software, we first have to get a handle on the architecture of code itself. I mean, how do we get from a human idea to something a machine actually does? Well, the answer lies in the very first step of any program.
Yeah, it all starts with source code, and you can really think of it as the blueprint for behavior, kind of like the DNA of an application. It's written by a person for other people to read and understand, but it holds the complete, exact set of instructions that will eventually tell a machine precisely what to do. Now, the real magic, the really interesting part, happens in the gap between these two. Source code is abstract, right? It's an idea designed for the human mind. But a processor, it doesn't understand ideas. It only understands concrete, machine-readable object code. And that translation from human-readable to machine-readable creates something called an abstraction gradient. It's like a slope going from a really high-level idea all the way down to a low-level physical operation. And this chart illustrates that abstraction gradient perfectly. You see, high-level languages like Python are super easy for us to write. They hide all the messy hardware details. But then low-level languages like assembly are way, way closer to the machine's native tongue. Now, this very model, this spectrum of abstraction, is actually a really powerful way to think about the mind. I mean, could our psychological thoughts be a kind of high-level language, while the firings of our neurons are the low-level machine code? But here's the thing. Applying this whole mind as software metaphor to the brain's actual processing, well, it's not so simple. In fact, it leads us away from the certainties of code and straight into the absolute deepest mystery of the mind. This is the big one. Our brains are performing trillions of calculations every single second. But why is any of that accompanied by subjective experience? Why do we feel the warmth of the sun or see the color red? This is what the philosopher David Chalmers famously called the hard problem of consciousness. It's not about explaining what the brain does, it's about explaining why it feels like something to be you. And this is right where that code metaphor really starts to fall apart. See, science is fantastic at explaining function. It can map the entire neural process from light hitting your retina all the way to you saying that's a red apple. But it has zero explanation for the private, first-person experience of redness itself. These subjective qualities, the redness of red, the feeling of pain, they actually have a name, qualia. And they are the absolute heart of the mystery. So, faced with this mystery, some brilliant minds have proposed some truly wild theories. You've got global workspace theory, which kind of imagines consciousness as information that goes viral and gets broadcast across the whole brain. Then there's integrated information theory, which tries to calculate a literal mathematical value for consciousness. They call it phi. The multiple drafts model. It takes a totally different approach, basically arguing our unified consciousness is just a clever illusion. And then you have thinkers like Roger Penrose, who believe the answer isn't in neuroscience at all, but down in the bizarre world of quantum physics. Now, these theories are incredible, but for the most part, they're just that, theories. But what if we could actually gather new data? I mean, on a massive global scale, to test the nature of consciousness itself. This is Adam Curry. He's a tech entrepreneur who decided to do exactly that. He compares his project to SETI, the search for extraterrestrial intelligence. But instead of pointing giant radio telescopes at the stars to look for intelligence, he's created an app that points inward, using our own phones to look for the signature of consciousness. The app is called Entangled, and its core idea is actually pretty simple. It uses the true random number generator that's already built into your phone's hardware. Now, why would he do that? Because decades of rigorous lab research from places like Princeton's Parr Lab have suggested something pretty incredible. That focused human intention and emotion can subtly, but measurably, influence the output of these random systems.
So here's how it works. You download the app and you can opt into different experiments. Let's say you're going to a concert. The hypothesis is that during these moments of intense shared experience, like 1,000 people feeling the exact same emotion during an encore, the collective data from all their phones might actually show a deviation from pure randomness. It is a massive crowdsourced experiment to see if collective consciousness can literally leave a footprint in the physical world.
And this incredible exploration of what consciousness is, well, it brings us directly to the frontier of artificial intelligence. And it forces us to ask a brand new kind of question. Look, today's large language models are amazing. They can write poetry, they can write code, they can have conversations that feel unbelievably human. But it's so important to remember how they actually work. They are sophisticated next-word prediction engines. There's no real reason to believe they have any subjective experience, any qualia. They are all syntax and no semantics. For over 70 years, the gold standard for AI has been the Turing Test. Can it imitate a human being? But as today's chatbots get scarily good at imitation, it's becoming pretty clear that that test isn't getting us any closer to understanding true sentience. And that's why Adam Turry suggests we need a new Turing test for a new era of AI. The question isn't, can it talk like us anymore? The question is, can it do the strange, unexplainable things that consciousness seems to do? So this new test would look for phenomena that decades of parapsychological research suggest are real properties of consciousness. Things like anomalous presentiment, reacting to something before it even happens, or mind-matter interaction, the very thing the Entangled app is testing. These are things that seem to operate outside the standard computational model of physics. Now, if an AI could do that, then we would really have something to talk about. Which brings us right back to where we started. This whole journey, from the pure logic of code to the deep mystery of the mind, it leaves us with this profound final question. If consciousness has these abilities that seem to go beyond classical computation, what does that say about our own existence? In this grand synthesis of code and being, are we the ones writing the program? Are we just the output of the code? Or is the truth something far, far stranger than we can currently even imagine?